Hi, how are you doing guys? I trust you're all doing well. I'm Alan Cantos and as promised, here is the video demonstration of the process in creating one of the CLT or cross-laminated timber structural connections which is based from a company called Rotoblaas. CLT demand continues to grow rapidly as the possibilities for using this versatile and sustainable material are vast. Here is the geometry information that I have downloaded from the website. I will be naming our parameters based on this information. So let's begin. First, open your Revit and create a new family. I will be using metric generic model family template. And from family category and parameters, I will assign it to structural connections, then accept the default settings. Don't forget to save first your file. Next, jump to left side view or right side view, whichever you prefer, and start tracing the profile of the angle using extrusion. Align the vertical line to the vertical reference plane and lock it. Align the horizontal face to the horizontal reference plane and lock it. Trim. Add dimensions. And assign a parameter to these dimensions. We will call it thickness. As you can see here, thickness is just 3 mm, and we'll start creating a new type which is called WHT 340. Thickness is 3 mm. Next, add a dimension for the height and another dimension for the depth. Height is 340, depth is 63. 340, depth is 63. Finish edit mode, go to front view, move this away to the vertical reference plane, add dimension and make them equal, add another dimension to control the width, the width is 60. Next, we will create these two triangular base brackets. So while we are in front view, let's create an extrusion for that angle shaped bracket. Align to this face and lock it. Align to this face and lock. Align and lock. Add dimensions. Assign a parameter to these dimensions, which is also thickness. As you can see here, that angle shaped base has a 150 mm total height. So let's assign a parameter, and let me call it angle base height. Which is 150. Let's move this up. Go to side view. Move this away to the vertical reference plane and lock it to this face. Align and lock. Similarly to this face, align and lock. Go back to front view, and we will be creating the other L bracket on the right side using extrusion. Let's trim them and align and lock them in places. Add the dimensions. And assign a parameter to these dimensions, which is also thickness. Go to side view. Move this away to the vertical reference plane and align it to this face and lock it. Align and lock. Now it's time to test the parameters. Okay. Okay. It's working. Next is to create a void extrusion to make the base angle triangular shape. And to do that, I will be creating a void forms, void extrusion. I will set the work plane, pick a plane to the side, and start tracing the triangular shape. Start from this face, lock, this face, lock, and that face. Just to make sure I will align and lock my reference point to that face and align this reference point to that face and lock it. Let's move this away. Select it, drag it until it snaps to the outside face and lock it. Do the same thing to the other side. Drag and lock it to the outside face. Now test the parameters. Alright. Next, go to front view and we will start creating the base plate. Again, using extrusion, align to this face and lock, align and lock, align and lock. Add a dimension and assign a parameter which I will call base plate thickness. It's just 10 mm. Finish edit mode, go to 3D view, move this away and align to this face and lock, align to that face, this face and lock. At this stage, I will be adding a bolt. I will be providing you a link for the bolt family that I will be using in this exercise. Go to plan, align the bolt to the vertical reference plane and lock it. Add a dimension, and this dimension is its hole position in concrete, which is 35 mm. I'll call this parameter as bolt location. Distance, which is 35 mm. Next, let us parameterize also this bolt by creating a new parameter, and I will call it bolt size, and I will group them under visibility. So in this case, looking at one of the information sheet, we can say that the type WHT340 is using 16 mm diameter bolt. Similarly with 440 WHT, 20 mm for WHT 540 and 24 mm for WHT 620. This one is 16 mm. Next, go to front view and we will start creating the holes, which is this small holes here, which is diameter 1, flange holes diameter 1, which is 5 mm diameter. I will be also sending you a link of this hole family that I will be using in this exercise. So I will be sending you the link for these two families that I use in this exercise for you to download. Drag a hole, drag, add a dimension, add a dimension, create a vertical reference plane, add a dimension, and we will call this first holes level offset. Going back to the information sheet, we can say that the first hole level offset for WHT type 340 is 150 plus H. Which one is H here? Which is hole position in timber 40. So 150 plus 40 is 190. Now let's align this hole to the reference plane and lock it. Align this hole to the reference plane and lock it. So for the three numbers holes, the distance is 20 and 20. So and the two number holes is in between. So we can say that from the center line it's 10 and 10. So we can assign a parameter for these dimensions, and I will call it 2 hole distance, which is just 10. Next, highlight that circular void and let's assign a parameter for the thickness, which is also equal to the flange plate thickness, which is also thickness. Because if we will not do that, I'll show you what will happen. So this one we parameterize the thickness, and this one we just keep it 3. If we update our flange thickness to say 10 mm, if you look behind, the other hole will not penetrate but if we update that to say thickness, we can see the hole that's punching through that plate. Let's move this back to 3 mm. Go to front view again, and let's start creating those 3 number holes. Just place them randomly, doesn't matter. The middle one, lock it to the vertical reference plane, and then the rest, the left and right side, lock them horizontally. Align and lock them horizontally. Add the dimensions. Assign a parameter, and I will call it 3 hole distance and this one is 20. Next is to create a horizontal reference plane. Add a dimension, and then I will call it, assign a parameter to that dimension, and I will call it group hole distance. So as you can see here, the 3 number holes and 2 number holes distance just 20 mm. So we can update that to 20 mm. And start locking these 3 number holes to this horizontal reference plane. Align and lock. Now, as you can see from these 4 types, this plate gets longer and longer and longer, and also the number of holes keeps adding up. So to do this, we will create an array, and then we will parameterize it, so that when this back plate extends to a certain distance, we can control the number of holes that will appear as well. To do that, let's first select these 2 number holes, add an array from here to any distance. Doesn't matter because you will be adding a distance anyway from this reference point to that group, and we will call this this dimension. I will assign a parameter, and I will call this array hole distance. We can do the same thing with the 3 number holes. Array from this one to that side. Just accept the default, making sure that the group and associate is thick from the reference plane to that part. And this is also array hole distance. Going back to the information sheet, we can say that the distance between 2 number holes and to the next 2 number holes is 40 mm. Now we will parameterize the array count. If you select that group, you can see the number 2 here, which represents the number of array. In this case, we have only 2. So selecting that, add a parameter, we'll name it 2 number holes array count, and I will group it under visibility. Do the same thing with the 3 number holes. Select that, select this array count, add a parameter and call it 3 number holes array count. Group it under visibility. Okay. So there's a file CAD here that I have downloaded, and it gives me this information here, which is for the type WHT340, we have 1, 2, 3, 4 array counts of 2 number holes, and 1, 2, 3, 4 counts of 3 number holes. Let's update that to 4 and 4, and there you have it. So we're done with our WHT340. Now I am ready to create the other 3 types: WHT440, WHT540, and WHT620. And to do that, click on Family Types, create a new type, and update this as WHT440. The height is 440 6063 440 6063, and as you can see here, the first hole's level distance or level offset is 20 mm higher than the WHT340. So in that case, if we have this as 190 previously, this will become 210, which is this one here. So same height, 150, and yeah, that's all. And in terms of the number of array counts, we have 1, 2, 3, 4, 5, 6 for the 2 number count holes. For the 3 number holes, we have 1, 2, 3, 4, 5, 6 as well. And bolt diameter is also 16 mm. Let's check. 16 mm. Okay. Next is to create the third type, which is WHT540. Create a new type, WHT540. So you only need to update this as 540. How many array counts? 1, 2, 3, 4, 5, 6, 7, 8, 9, and the 3 number holes, 1, 2, 3, 4, 5, 6, 7, 8. So this is 9, this is 8. And in terms of geometry, so it's the same. Hole size, bolt size is 20 mm. Hole position in concrete, it's hole 35. We're done with the third type. Let's do the final type, which is WHT 620. 620, 8083, and 38 base bolt 38. And in terms of array counts, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 10 3-number holes. In terms of bolt size, we have 24 mm. There you have it. We have now completed this WHT CLT angle bracket connection with 4 types: WHT 340, 440, 540, and 620. I think that should be it for me. If I've left out any info that you want, or if you have any questions, just let me know and I'll do my best to answer. Thanks very much for watching. Cheers, have a good day.